Hello everyone. So in this video, let's look at how we can program using Omron CX program. Now let me start by reminding about the addresses in Omron. So as you can see here, addresses from 0 to 99 can be used as inputs, and addresses from 100 to 299 as outputs, and anything above 300 will be reserved for advanced communication protocols. Like for example, if you have some human interface devices, those will use addresses above 300 and so on. Now, and one other thing I want to note here is that if you take some address, or let's say 0.00, so in CP1E you can have up to 16 addresses. That means you can go from 00 to 15. So that is one important thing to note as well. Now let me move on to CX programmer here. So you can find it under Omron. So once you open CX programmer, as usual, we can create a new project and select whatever the PLC we are using. So here I'm going to select CP1E, and we will be taken into our ladder environment. Right now, so basic input outputs we can use normal connection. Now to add an input, I can say 00. I'm giving an input address, and then for an output I can give 100.00 as my initial output. And it's a good practice to give a comment. So here I can say input, and for an output I can say, let's say, out1. Now in blue color they will be indicated in your ladder diagram, and your address will be specified here. Now one other thing we did about is how we can store things in memory. Now what we did in previous lessons was basically we had, now let's define a memory, and I will try to keep a memory in the location 10.000, let's say, and let me name it M1. So here, for if you wanted to store memory, what you can do is you can use the latching and delatching technique. So here what we have to do is we have to add the same memory, and to delatch you can use some other signal. So for example, let me use this one. I'll say input 2. Now this should be a normally closed switch. So yeah, now the same thing we can do. I will show you a simulation of this. So before going on to the simulation, let me introduce a new command. Now for advanced commands you can add setting and resetting. There are internal modules. Instead of doing this kind of a latching and delatching, we can use internal available instructions already in the PLC. So for example, let's try to use the same input, and in order to latch, now here you can go into instructions. So this is the instruction icon, or we can press the terminal icon I. So in this case you get a new instruction. So here instead of an address, what we need to type is a syntax of an instruction. So let me quickly move on to setting and resetting. So here you can see the syntax of setting and resetting is basically, you can say set with the needed address to set a memory, and to reset a memory we can use rset with the same address to reset the memory. Now let's try to set the memory location 10.01, and okay, so that is there. And again let me use the same input to reset this memory as well, and we will see whether this is equivalent or not. So I'm using input 2 to reset this memory location. So to reset, what I can do is I can again add an instruction called rset with the needed memory location. That's going to be 01. So here you can see this is broken down into 2 rungs, but if you look at the operation, it will have the same effect. Now in order to show that this is the case, let me get the output. Let's say, let's use the input. So here I can say 10.00 just to indicate one indicator. Let's go with 100. Let's go with 100.01 as an indicator, and again in the next run let's try to get the next memory location which we are using. So here let me rename this memory location to be M2. So here you can put M2 as a comment, and then let's get another output here just to look at the behavior. 0 2. Now if you let's run the simulation, you can click on start simulation, and it will prepare the simulation, and we can check and see whether it's running. Yeah, so okay, basically the simulation is now running. So here you can see our initial input. If you set it and reset it, so using the first method which I have done here, 10 is latched. Here you can see also 1001, the second address is also showing latching. So here you see the same behavior. Now if I delatch, or if I use this to delatch the memory, here you can see both these methods are delatching the memory. So here this statement is equivalent to these two statements. Depending on the preference or depending on the clarity of the program, you can use either of these methods. So it's fine. According to your preference, you can do this. Let me stop this simulation. Okay, so that is how you can basically work with memory in CX Programmer. Now let me remove this, and okay, so moving on. Now in addition to memory, there are timing is an essential thing to do to keep with PLCs. So in order to do timing, there are certain built-in timers inside a PLC. So here in this syntax you can see actually there are two types of timers which we call retentive and non-retentive timers. Here I have shown you how non-retentive timers can be added to the ladder diagram. Now there are specific commands. Depending on the time interval you need, you can select whatever the timer you want. Now let me move on to the next slide. So here you can see the completed syntax of a timer. So what you need to put is basically you need to add the timer, whatever the timer tag, so that would mean TIM. So in this case it's going to be TIM, and then you need to put an address which can be anything from 0 to 255, and then whatever the amount of delay or the number of counts you can put after a hash symbol. So let's try this out and see how it works and how a timer can be added. So let me put another input here. So I'm just basically using the same input. Now again, to add a timer, what you can do is you can click on I, and here in the instructions you can type whatever the timer you want. So the first thing is the timer command, and then the address of the timer, and then followed by the value. So let's say I want to count 200 counts of now TIM is a timer of 0.1 seconds. So if I count 200, that would mean 20 seconds basically. Now to get to give a name, it's possible to add a name, let's say timer 1. Okay, so here you can see this is the complete instruction. Let me connect this. Now things to notice here is that the timer address is shown here in the second box, and in the third box you can see the value the timer is counting. So basically that is the amount of time this will wait until before triggering if this is turned on. Now to get the output, what we can do is we can use the address T followed by the address. So T0 means the time. So we are getting that state, whether the timer is triggered or not. We can use that to trigger whatever our outputs. So for example, let's get my usual output 100.00. Now if I run the simulation, and let's so if I set this to high, here you can see immediately your amount is reducing, and now this simulation, since we are doing it in a simulation, the timing will not be exact, but you can see here the timing is decreasing, and once it receives 200, or once it goes to 0, here our output should trigger to be high. Now this timer is something called a non-retentive timer. So the idea is, now if you cut off power or if you disconnect this here, the timer counter will reset automatically. So if I set it here 0, this will automatically reset to 0. Now if I again set it to 1, here you can see it's starting from 200 again and counting down. Now even at this point, if I reset, the counter value or the timer value will be resetted. So that is the idea behind non-retentive timers. Now let's say if you want to now let me put a rung above, and add a retentive timer here as well. If I just move on to the syntax here again, so it's just like the timer. Here also you need to give the address and the delay. One thing to notice is that timer, the command is different, so you have to have TTIM. Now let's trigger this using the same input, and to add the timer, let's add the TTIM. So that is a 0.1 timer, and now here I have to give a different address. Now to give the same time interval, I can go as 200. Now in addition to our counting or the timer enable input, one thing we need is, now these are non-retentive timers. Now in order to clear this timer, we need another input. So here I can add a second input, let's say 01, and here I can say just clear or whatever. Like input 2 is also fine. So input 2, which is connected to the clearing pin. So here this will, as usual, show you the address and the amount of time we are counting, or the timer is elapsing, will be shown here. Now if you do this simulation here, let's start the timer as usual. So both the timers should be triggered at once, since we are using the same input. And here you can see now this is counting down. Now let me again set this to 0. Our usual timer resets back to the original count, but here you can see the amount of time elapsed is saved in the retentive timer. So this is the difference between retentive and non-retentive timers. So retaining means keeping. So basically you can get the literal meaning of retentive. So that would mean, now if I keep this high continuously, you can see that this timer will resume counting from the place where you stop. So that is kind of it. And now this timer has triggered. Now I have not taken that as a output, so we will not see any output. So let's wait till this also triggers out. Okay, now here you can see both the timers are triggered. Now if you want to reset, what you can do is timer 1, you can turn it off, so then the timer state will be cleared automatically. But here you can see still this timer is considered to be active. If you want to clear a retentive timer, you have to specifically give a clear input and then momentarily release it. So basically that's the idea behind a retentive timer. So these are kind of like the most basic operations you will be needing in order to build certain things in applications. Now I think the next remaining thing for a very basic explanation is how a counter will work. So in addition to timers, in PLCs, in number-on PLCs, there are timers. So here we have specifically two types of timers: CNT, which is an up counter, as well as an up-down counter. We have a command called TNR. So basically these two commands we can use in order to implement counters. Let's say you want to count some number of packages passing. For a situation like that, we can use these timers. We can count the number of inputs we are getting, or things like that we can try out. So if I look at the syntax in detail, so here you can see a block diagram, like the ladder symbol, and so this is for a up counter. So here you can see the total counts is displayed in the bottom, and the current counts, when it is running, you will see that on top of that as a fraction. Now now if I go on to an up down counter, so here in addition to this resetting and the increment input, we have another input which is called the decrement input. So basically the idea is we can reduce the count, or we can count down using that input. So let's try these two out in a simulator and see how this works. Okay, now here what we have, let's again start with the input. So as usual we can go with this, our input, and then to test the counter, let me put a counter called, so the basic syntax is CNT, then you have to give a counter address and then the value to count. Now for this example I'll give 10, so I can give a name, a comment here, counter, say counter 1. Okay, so here again we need a second input to clear the counter. So to that we can give another input. Here input 2, I'm giving it to counting. Now just to get the output, what you can do is, as same as in timers, you can say C000 to get the counter triggered, or whether it is high or low we can get using this. So what we can do is, let's take an output here, say 100.00. I can make that. So basically now if I run the simulation, what we should see is, initially we can actually clear the counter. So you can clear it. You can see here the count is hold on at 10. Now if I give an input here, so you can see that the timer is counting. It's basically counting the rising edge of the signal. So that is basically the idea here. And if I keep on counting for 10 occurrences, here I will have, let me continue. So now it's 3, 2 and 1, then 0. So we should see the counter triggered. Okay, now the count is triggered. Now even if I turn this off, still the counter will be kept on because it's storing the values. Now if I want to clear this input, what I can do is, I can momentarily set this high and low, then that is clear. So basically that is how you can use a actually this is more like a down counter, even though I'm saying it's an up counter, it's a down counter. So it's a correction, I think, for the previous explanation. Okay, now let's also look at, instead of a timer, let's try to put an up down counter here. So we can say CNTR with the address again, with the same address even. And for simplicity, let me add count numbers 3. So okay, so here we have to give another input to decrease. So here let's go with I'm just going to call this input decrease, DEC. Okay, now let's try to simulate this and see what happens. If you clear the input, I think it will be set to 0. Yes, so the count is set to 0 once you clear. And now if you increase, what should happen is, you should see the count increasing. Okay, so then if you decrease while this is going on, here you can see the count is decreasing. So basically that's the idea. Now if you trigger this, let me try this, let me get this to trigger. So the next state, it should trigger. Okay, once this is triggered, it will automatically clear the count to be 0, even if I decrease the value from here. So basically that would go to the next section, that is going to wrap around and count to the maximum value. Now even if I clear, it should still if I clear and again then set this to 0 and take it to high, again you can see that even if you down count from the minimum value, it will automatically trigger the counter. So this is basically, it's like a ring counter we are having. So that is kind of an idea what you can get. Right, so these are the basic things you will be needing in order to implement reasonable implementations using Omron. Yeah, so I think this completes almost all the set of basic instructions you will need in order to implement simple things. So if you have any questions, you can post in the LMS or directly ask me if you have. Thank you.